So this session we will see the implementation of linear regression model for the given problem statement in the syllabus using Jupyter Notebook using Python programming. So first we need to import here all the required packages. So here I am importing all the required packages. Import NumPy, Matplotlib and Pandas. Then you can read your data set. Now my data set here is the rescore data set. So which is in the hours.csv file. So here my file name is hours.csv that already I have uploaded here in the home of the Jupyter notebook. So here is my data set hours.csv, right? So because it is in the home page, we no need to give the complete path. So here by using panda.read_csv method, we are importing this data into the variable data set, right? So next, I want to divide this data into X and Y variables, right? So here using iloc method, I am separating the X and Y variable where Y represent my target variable. So here, if you display X variable, so we'll have all the values of the hours 10, 9, 2, right? And so on. And Y variable is having the rescore values, right? Which is my target values, right? That we discuss in the problem statement. Now, if you plot here, these values using scatter plot. So plt.scatter bracket x comma y. If you see these values on this scatter plot, you can check the shape of the data set. See, before going to build any model, student, you can check the shape of the data set, and by just observing these data points, you can identify which model will be suitable for the given data set, either linear model or non-linear model. So here, if you observe, my data set is a non-linear actually. It is having the curve shape. Right, all the points are not in the one straight line. So actually my non-linear model will solve the problem here, but it is given in the syllabus problem statement ki use linear regression model to solve this problem, and that's why we are using here linear regression model. So definitely student, because my problem as data set is non-linear, but we are building the linear model for the same, my accuracy will be less. That also we will check using the function, right? So we will check accuracy of the model for this data set using linear regression model. So this is my shape of the data set, right? Now next I want to create the model. So here from sklearn.linear model import linear regression. So here we are importing the linear regression class from this linear underscore model sklearn library. Now next, once you have done this, you can create the object of this linear regression model, and also you can feed the model. So here we are creating the model. So this output linear regression shows that my model is created successfully. In the feed function, we are passing here X and Y variable, that is my training data set, right? Now next is what? Once you have created this model, right, you can measure the accuracy. But before measuring the accuracy, just one point, that is the part of the problem statement. I want to predict the rescore of the hours 8. So here is the statement I am executing to predict the value rescore of the given query point 8. So this 8 point hours we are passing as a parameter input to the predict function of this regressor model, right? So y predict will have the predicted value for this query point 8, and that we are printing here with the help of print function. So here if you observe, my predicted rescore is what? 49.28 for this 8 hours, right? So now you need to check whether this value is correct or not. You don't know the accuracy, so we can't say that this value is correct, right? So here we will measure the accuracy of the model by using the score function, right? So here the same value, right? The same value we can calculate with the help of equation also. Now we use here predict function, right? So before going to discuss the accuracy part, just I want to show you the alternative method to predict the value or score value for the given query point using the alternative method. So here instead of using directly predict function, I will use the equation of the line. So here for that I am taking the input from the user. So here is the statement for taking the input from the user, right? So here if you see my statement will ask you the value. So here my value is 8, right? The same value I am giving as the input here. Now the same, I want to predict this value of the 8 hours, right? Using the equation of the line. So you know that there are the inbuilt parameter, that is coefficient underscore and coefficient intercept, that I will pass to the equation to predict the value of the query point or to predict the score of the value. So here I am building the equation, right, using the inbuilt parameter, right? So here is the equation equal to regressor dot coefficient into hours. Here my hours is nothing but the 8 that we have taken from keyboard into the hours variable plus regressor dot intercept. So intercept underscore and coefficient underscore will return the slope and intercept of the line, and equation will return here, right, the expected value, predicted value of this 8 hours by using this equation. So now I want to print this equation. So here is the code for printing the value of predicted value of the score and also the equation. So if you observe, my predicted value is 49.28 that we have also obtained using the predict function, which is same as this. And my equation of the line is y equal to 4.58 into 8 plus 12.58. If you want to extract this value, right? So this value will give you LR dot, here my actually, my object name is regressor. So regressor dot coefficient underscore will return you this value. So 4.5 that we have used in the equation here. If you observe this value 0.4 we are using as a in the equation, right? And here also we are using in the equation regressor dot coefficient underscore. Similarly, you can extract here the intercept. Regressor dot intercept underscore. So this will return you intercept of the line, which is 12.58 that we have used in the equation. So this is the alternative method that we have used to predict the value or the score for this example, right? For the given hours. I hope student you are clear with this. Thank you. In the next session, we will discuss the regularization techniques to improve the accuracy of the model. Here, the one part is remaining, that is printing this accuracy of the model. So here you can use the function lr dot regressor dot scores, right? Before that you need to uh, pass here the expected value of the complete data set, right? Only for one query point we have calculated here the score. So for that, first you need to calculate here, right, the output of all the values in the training data set, and for that the code is here ypred, copy here, just I want to print the ypred1 instead of ypred. I am using regressor.predict. So instead of single query point, I want to pass here my complete data set, right? My complete data set is in X variable. So this will return you the predicted values of all these X points in the data set. So if you run this and if you display Y underscore pred one, right, you will find the expected values. So if you observe student, these are the predicted values by the model for this given X data set. And you know that what is my X? So here my actually Y is nothing but the actual Y, and this is predicted Y that we will compare with these values. So here for this first X value, my predicted Y is 58 and here it is actual, it is 95. There is a huge difference between the actual Y and predicted Y. Similarly, for the second data point, right, ours, my actual Y is 80 and predicted Y is 53.87. Again, there is a huge difference between this value. Then here it is 10 and here it is 21. Again, there is a difference of 11. Then here it is 50, here it is 81. Again there is a huge difference. Here it is 45, here is 58, next value is 98, here predicted value is 85. For 38, predicted value is 63. For 93, it is predicted value is 85. So if you observe student, the accuracy of the model is very less. No value is near to the actual value. Exactly, my model will never give the exact output, right? The rare case when my accuracy is 100%, but the expected accuracy is actually 90% and above. But here my model is not giving this enough accuracy. So how you will check this accuracy? So my formula is regressor dot score, regressor dot score in bracket you can pass here y comma y pred, y underscore pred 1, and if you run this you will find the accuracy. Of course my function name is here. Here instead of y, here we need to pass x and y variable. So this will return you the accuracy. Here my accuracy is 43%, right? If you observe student, my accuracy is 43%. Now how to improve this accuracy? Here instead of actually y and y pred, right, that we pass in the classification techniques, but here my score function actually require the x and y data set, right, to calculate the accuracy of the regressor model. So here we have obtained the accuracy of 43.70%, because accuracy is very less because my data shape is non-linear here. So in the next session we will discuss how we can improve the accuracy using regularization techniques. Thank you.